We are talking about the exhaust system, and you see that it has a different color here. It's this pink or whatever is for supply. The blue is for return. Well, I don't mind. And then this duct has a different color. This is the exhaust. So we have two supply diffusers, 1 and 2 in each restroom. And then we connect it horizontally to this shaft, and then we go all the way up. So we are going to do something like that. Well, those are too big. I'm going to edit type. And instead of 2 feet by 2 feet, I'm going to type here 1 by 1. And this connection, it's going to be 8 inches. Okay, that looks more reasonable. And well, we can place one exhaust here, another there. And I'm going to copy the same layout here. First, the position. By default, this Revit places the exhaust element, every diffuser, every grill, it's on the floor. It doesn't make sense. So we have to select both, and we have to change the elevation. Elevation, at least 10 feet. And okay, at least the elevation should be 10 feet. So now that we have the right elevation, we can copy them to the same place. On the other restroom. Oh. Okay, here. Now we need a pipe. If we look at the original, we need a pipe. I don't like this, so I'm going to put this pipe in the hallway. Okay, so I'm going to move this pipe here. So I'm going to, well, it's not a pipe, it's a duct. And in duct, you see that we have the system type. We have by default is supply, we have return, and we have exhaust. So you have to select exhaust. What's the elevation? The elevation, I think it works because the middle elevation here, it's 11 and 4. I'm going to type 12. It has to be above the diffuser level. If the diffuser is at 10, then the duct has to be at 12, kind of. And then I'm going to draw the duct. And I can connect now with flex ducts. I can connect all these ducts here. Take a look at the 3D view, because by default, you know that Revit does this. So the T by default is looking up. Doesn't make sense. So I'm going to rotate it. And now I'm going to connect with a flex duct here. Okay, look at this. We have to be careful because we have designed the pipes, the water or hot water and cold water pipes, and now there's an intersection between the water pipe and the air duct. So if that happens, I have to reconfigure the, yep.
What was the size of the exhaust screen?
The pipe, the diameter, you mean, or the square?
Square.
1 foot by 1 foot. So if I have to connect this, and I have the supply pipes here, I'm going to make the duct Okay, so I have the duct here, and now there is no intersection between the water pipes and the duct. So be careful with those small details. And now we can connect with a flex duct, this one and that one. Okay, so be careful with this. And now we need to do the same with level 0, with these two. I think we can copy the T here. If we copy the T, again, this doesn't work well because you see that the pipe goes through the T, and we should stop this pipe here. And now we should draw another duct there. Okay. And now from this T, we can draw a duct, and the last one, it's a flex duct. And the last one, we draw a flex duct right here. Again, the T is not in the right position. So I have to delete the duct, rotate the T, and draw another flex duct again. Okay, so we have done it before. It's easy, but be careful because we can make small mistakes. So now I have to copy, but look at this. It's so messy that if how can I copy, how can I select these exhaust ducts without selecting all the things that I have here? We can either work with a section box. If you're working with the section box and you drag this here so that we see only the exhaust system. And now I can copy it to the second floor. So I can select all these ducts here, copy to the second floor. Finally, because I have this shaft, again, be careful because we have pipes there. So I can draw a duct with a 45-degree angle. Then I can do this. And if I want to go all the way up, I have to change the elevation to, say, 50. And on the 3D view, well, it's way too high. Okay, this exhaust pipe has to go beyond the roof level, around 6 feet above that level. Now we have to connect this to the first floor. If you click on this elbow and you click this plus sign, that becomes a T. Okay, so it's way easier to connect it. The problem is that if we want to go down from the 3D view, I can't go down unless I change the elevation. If I change this elevation, then I go down. Okay. And now on level 0, I have to connect this and that. So I can go 45 degrees here. then there, and I hope it will work. Yeah, it works. Okay, it's very easy compared to the supply and return diffusers because we have fewer diffusers and we don't have to connect these to anything. We just have to get rid of the air. It's very important that we don't have supply diffusers in the restroom. I explained why, because in the restroom we have to extract the air. If we supply air, we can consider that part of the air in this room can go through the building into a different room. We don't want the air in the restroom to go to different rooms. So that's why in the restroom, we only have the exhaust. We only exhaust, and then the supply diffusers, part of the supply air will enter the restroom, and then it's extracted and we get rid of it. Okay, so this is one of the things that was left in the building. It's the exhaust pipe. And if we go to level 15, we see that the exhaust, it has a different color. And that looks much better. Okay, supply, return, and exhaust air from the restrooms. What's next? The rain downspouts. We explain how to do the drainage. So it will be there. We even calculated the size of the soil stacks, the vent stacks, the horizontal drainage. We have already calculated that. And today we are going to focus on the rain. So this is our roof. And if this is a flat roof, if it's a tilted roof, it's different because the water goes out directly. But in a flat roof, we have to collect the water and then we have to go to move it down. We have already designed some of the shafts because if we have shafts, that means that part of this, well, the water downspout, the rainwater downspout, will go through these shafts. How many shafts do we have? 1, 2, 3, 4, 5, and 6. I think this one is too busy because all the air ducts are here and the pipes going from the boiler. So I think we will use only 5. 1, 2, 3, 4, and 5. So we have to divide this roof into 5 different parts, and each part will be collecting the water to this vertical pipe. So let's do it. There is a lesson, the lesson on drainage. The last part of this lesson, you can find the theory of the storm water or the rainwater. We're talking about flat roofs. So for the flat roofs, we have to divide the roof into different parts, and we need a vertical pipe on each part. And then we have to go all the way down. It's not good using horizontal pipes for the rainwater. So that's why we need to find out where the shafts are, because we have to go all the way down, just 2 or 3 feet under the basement or the floor slab, the first floor slab. And if you see, this has a slope. Okay, so the horizontal, it's not that horizontal because it has a slope here. And this connection, it's always a 45-degree angle connection. So the same thing we did for the drainage, we have to do for the rain. So we have to do all this. Okay. And there's a theory. First, we need to understand the rainfall intensity. It's inches per 15 minutes of rain. And if we are here in New Hampshire, we have 5.4. Okay, so we have this line here. It's 5.4. It's not the amount of rain that we have throughout the year, but it's the maximum amount of rain that we can have in just 15 minutes. So here in Texas or Louisiana or Mississippi or this area, we have a lot of it's very demanding because we can have a lot of hurricanes or tornadoes or whatever. So that means that in just a few minutes, we have a lot of water. So here probably we have more rain, but it's less violent. So we have to be careful, especially in those places in which it never rains, except when it rains. Anyway, in New Hampshire, we have 5.4. So this is 5.4. And now we need to go to that table. So in that table, it's quite easy. This is the rainfall, inches per hour. Well, it's inches per 15 minutes. So this is wrong. It's inches per 15 minutes. So if the rainfall is 5.4, we have to select the following one. It's 6. Okay, so this is the rainfall, 6. Now, this is the size of the downspout, and it depends on the area. In this exercise, or in this design, there are 4 downspouts, and the area is 800 feet each. So if we have 800 feet for each downspout, 400 is not enough. We have to go to this one, 1400, and the size of this would be 3 inches. But now we have to look at our building, because in our building we have all this roof area. We decided that there's going to be 5 downspouts because we have 5 shafts. What's the size of the building? The size of the building, I think it was 70 times 141. Okay, so the roof area is 140 times 70. It's 9,800. Let's round up to 10,000. If we have 5 downspouts divided by 5, this is 2,000. Okay, so the roof area per vertical downspout, it's 2,000. So we come back to the table. So 1,400, it's not enough. We have to go to the following one. It's 3,000. So that means that the size of our drain is 4 inches. Okay, so it's quite easy. First, we need to know this number, the maximum rainfall intensity. Then we have to go to this table. This is the rainfall intensity. We have to select the closest highest number. Then we have to divide our roof into different parts, depending on the area of our roof. We come here, and then we go up, and we find the size, the diameter of this downspout. So it has to be 4 inches. And we have 5 of them. 1, 2, 3, 4, and 5. So now we have to design it. So I'm going to select pipe. You see that by default, the system type is hydronic supply. It's not hydronic, it's sanitary. And let's see what we are doing. We are on level 30, but Revit does this. By default, the middle elevation is -16. Doesn't make any sense. So let's type here into this cell 0. And the first thing, it has to be a horizontal one. Then we will get rid of the horizontal, but we have to go to the shaft. And now we have to change the middle elevation to -50. And then we have to go horizontally again. And let's see what we have here. Well, there's so many things that it's difficult to find where the rain, it's okay. So you see that it's here. I use this shaft, and it's just a vertical pipe. Now we have to close this shaft, and then we need to collect all the water there. Okay, so that's a detail. We're not detailing the building now, but we know that the downspout will be here. And now we have to copy this 5 times. Well, be careful because now there's a conflict. So make sure that there is no conflict with any air ducts here. And then copy 1. And copy that again. 2, 3. Again, be careful with the pipes. And 4. So on this 3D view, we should have this 1, 2, 3, and 4, and 5 downspouts. Okay. What's the depth of this? Well, I think I'm going to create a new level because that's level 15, but then we have the floor slab and then we have to go down. So I'm going to create a new level. Let's say level, we can go 4 feet downwards, and that would be level -19. Okay. And I'm going to drag all these elements to level -19, sorry. And that's going to be the level of my drainage. So that's pretty easy. We have different downspouts here. We have 1, 2, 3, 4, and 5. Okay, so we have 5 downspouts, and now we have a vertical pipe. So I need a vertical collector here. And now I have to connect all these. Sorry, this is a horizontal one, so I need to connect all these to the horizontal. The size of this is, if we insert, this is 4 inches. So all the downspouts are 4 inches. And what about this one? Because I'm connecting a lot of 4-inch pipes to the same horizontal one. There's another table here. The next one is about the size of horizontal rainwater piping based on maximum rainfall and roof area. Okay. So we have to base that on the maximum rainfall and the roof area. What is the rain? Well, but first we have the slope. You see that here we have 1/8 inch per foot slope, 1/4 or 1/2. 2% slope is 1/4 inches per foot. Okay, we can use the more slope, the better. So that would be better. But if we are consistent, we have been using, yes.
Can you show what your spout looks like? 'Cause I'm a little behind.
I didn't change the size. Okay, so by default, we have a 6-inch diameter. I need 4 inches. So I have to select all the spouts here and type 4.
Where are they placed?
They are placed in the shafts. Okay, so we have 1, 2, 3, 4, and 5. I have placed them on the shaft because I had already designed those shafts, so it doesn't make any sense opening a new shaft for the downspout if I have those. So it makes sense that the downspouts are there. Okay. So let's keep going. We were calculating the on that table based on that slope. It's 2% or 1/4 inch per foot. That's the slope. Then we have the maximum rainfall. The maximum rainfall it's 5.4. So we are going to use this one, 6. And this number is the area, but it's the area of the whole building because now we are connecting all the water that we collect on the roof. We are connecting that to the same horizontal element. So if the area of this building was around 10,000 square feet, so we are here. Okay, so we are that slope. This is the number of the rainfall, 6. Then this is the number of the roof area, the total roof area. And then we have to go all the way in this direction. So 8 inches will be the size of this horizontal pipe. So that pipe would be 8 inches. Eight-inch pipe. Okay, and now we have to connect all these vertical ones to this horizontal. We could go like this. But again, when we are working with drainage, it's always better having like a 45 degree angle to connect all these things. If it's too far from this, we can have like something like that. Okay, so we can go this way, and then when we are close to the pipe, we have the 45 degree angle. The same thing here. Okay, so we're going to do something like that in the Revit file. The thing is that this pipe, it has a slope. Okay, so horizontally, it works, it's very clear. But if we look at the section, there will be a slope on this pipe. So the connections that we have at each downspout, it's going to be slightly different. Okay, so it will take a little time to figure it out. But what we are sure is that we start at this level, the new level that I created here, let's say level -19. So if I'm on level on the basement, we have the downspouts here. I'm going to create a new pipe. This pipe is sanitary. It's not hydronic, it's sanitary. the pipe diameter is 8 inches. This is what we have calculated. And the reference level, it has to be on level -19. That's the new level that I created, okay? So again, select pipe, select the right diameter, select the right system, it's sanitary, and then make sure that the level is -19. But the middle elevation is not 54. So again, be careful because Revit does whatever it feels like. So it's level -15 and make sure that the middle elevation is 0. And now we can place the pipe, I don't know, let's say here. We don't see it because we are on level 15. If we don't see the pipe, the view range, make it unlimited in the bottom. And now we will see this pipe here. Okay. So now we have to connect this and that. But before, be careful because we need the slope, okay? So we have this starting level and this elevation, it's on level 19 and the elevation is 0. What would be the last elevation here? It depends on the slope. It's a 2% slope. What's the length? The length is 109. You see that this length is 109. So what does it mean? If we're working in section, if the length of this pipe is 109 feet, that's length. If that level is 0, then we have to go down because there should be a 2% slope. Okay, if we move it down with a 2% slope, what is this? 2% slope means that in 100 feet horizontal, I have to go 2 units vertical. This is a 2% slope. So if this is level 0, this has to be level negative. It's 109 feet. So it should be slightly more than 2 feet. So I can do 2 feet and 2 inches. Okay, kind of. If it were 100 feet, that would be 2 feet down. If it's slightly more than 100 feet, so it's slightly more than 2 feet down. Okay, so now we have to create that slope in Revit. So if we start here at level 0, the last level should be -2 feet and 2 inches. So we move it down this way. Okay, so that's the slope. Remember that in every single drainage system, all the horizontal elements are not horizontal. They do have slope, like this. Okay. Okay. So now the challenge is to connect this to that pipe. I think we can do it easily with the first one. Okay, the first one is here, and we have to connect it to this pipe there. So let's go to this level -15. So I can draw a pipe. I can go with this 45-degree angle up to this point. Will it work? It works. And now I can get rid of this and I can close this and it will be an elbow. Okay, so that's the first. And we go this way, 45-degree angle. Now I need to connect that one. So I'm going to try to do it from the 3D point. First, I will go horizontal, but then when I'm close to this, I'm going to go 45 degrees and it doesn't work. Okay, so that doesn't work because now there's a slope and we have to move this a little down. How much? Let's try. So the middle elevation here is -49. I'm going to move it to -49 and 6 inches. And let's try again. Now it works. Okay. So now let's try to do the same with this one, but this one it's gonna be even. Okay, so now we're going to try to connect these, but the levels are different. We can, instead of doing this, I can try to move it down, something like that. And then I will draw pipe. And then 45-degree angle here doesn't work. So probably have to move it a little downwards. Let's say -49 and 10 inches. Let's try now. I think now it will work. Yeah. Okay, so it's a little tricky because if this is the slope, if we have a slope here, every connection has to be a little lower. If this pipe was 49 and 10, probably I will move this, draw pipe, and I'm going to move that -50 feet and 2 inches. And let's try. Draw pipe, 45. It doesn't work. Probably because it has to go a little, instead of 50 and 2, let's try 50 and 4. Draw pipe, 45. Oh, that work. Do I have to move a little bit more? Okay, now it works. And the last one, from this point, draw pipe. I go horizontally. I move it. That was 50 and 6. I'm going to move this one 50 and 8. And try now 45 degrees. It works. Okay, so it's a little, because of the slope, it takes a little time to do it. But now everything is well connected to the slope. Are we done yet? No, we're not, because there's something else. We have always a perimeter drainage in the building. What is that perimeter drainage? This. Storm drain. Okay, this is it. You see that around the house, we have this pipe all around the house, and then we have to connect this again to the storm drainage before. Yeah, so there is always, they call it French drain. Okay, French. But all around the house, we have a pipe, and this pipe collects the water that we don't want to get into the basement. Okay, so if we look at the basement drainage, this is it. All around the building, we have like a trench, and we fill this trench with aggregates, and at the bottom of this trench, we have a pipe. Okay, so we have a drainage system here. So to prevent all this water to hit the basement wall, we have like a loose soil. Loose means that we have aggregates like this. So it's not a compact sand. So the water filters, and the water ends up in this pipe that we have here. Okay, that's the idea. But when we have a basement, we always have this drainage, perimeter drainage system around the building. How can we do that in Revit? It's just a pipe all around the building. If now the good thing is that we know the level of this pipe. So the level of this pipe, it was -2 and 2 inches. So if this is level -19, so that will be -21 feet and 2 inches. Okay, so we are level 15. No, and now we have to draw another pipe, sanitary. The diameter, we can make it 8, doesn't matter. Now we are in reference level, it's -19, and okay, let's do it. Pipe, sanitary, the diameter is 8, and then we are on level -19, and the mid elevation it's 2, -2 feet and 2 inches. And now if I go all the way here, the connection will be, okay, so let's do it. We have this. This one. This one. The connection should be always a 45-degree angle. So from this point, draw pipe, 45-degree, connect to this, and that works. And from here to here, 45, and that works. And now this is connected to the city storm drainage. Okay. So we are done. What have we done today? The exhaust. Okay, so remember that the first thing we did was the exhaust system from the restroom. Just connecting this to a vertical pipe, getting rid of it. And then we have created the vertical rain downspouts. We have to connect this to a horizontal pipe with a slope. And then we have these elements connected to that. This has a slope too. Can we change, for example, if I change the elevation of this pipe, if I change this elevation to 0 and 0, and now I change this final one to 0 and 0, I only have to connect this. I should be able to connect it. Okay. And okay. So now I have the same slope in this perimetral drainage. Why is that important, everything that we are doing here? Because look at this. This is what we have after pouring the concrete on the basement slab. We have all these plastic pipes going up because the rest of the things are buried, are underground, and are underneath this floor slab. So if we want to continue with the basement, the first floor, the second floor, the first thing that we have to do is to design the underground pipes. And then when we have a vertical downspout, then we have to go up. Then we have to pour the concrete. And after the concrete dries out, we have the vertical pipes. Okay, so it's the last thing that we have done in this building because it's the last thing, but it's the first thing that you have to do in when you're working on site. So the first thing that the workers will do is to draw the footprint of the building on the site, and then start designing the buried drainage, rainstorm, and even the drainage from the toilets, all the pipes. This is the first thing that we have to do. Okay, because if we don't do that, we won't have drainage. And it's not, oh, I forgot to, oh, do you remember if we created all these pipes underneath the basement? No, I don't remember. Okay, there is no option because the building will be there, all the floors will be there, and you can't perforate the basement slab to try to create the drainage system. It's the first thing you have to do before doing anything else. And then make sure that you have all these pipes going up so that when you pour the concrete on this floor slab, you can connect the vertical pipes here, and then they will go up to the roof. Okay, so it's something quite important. we are not even aware that that these pipes exist. But if they weren't there, there would be a lot of issues in the building, a lot.